Good morning, students.
Good morning, sir.
Good morning, sir.
Good morning. So, students, yesterday we have started. In the last class, we have discussed this Laplace transform, where we have seen like two-sided Laplace transform, one-sided Laplace transform, and then we have seen the Laplace transform some standard function, and after that we have drive one table. Like for yesterday, I have discussed. Might be you people have seen the recording or not. I'm not sure. Uh, but actually for any transform, like since we are talking about the Laplace transform, so we are talking about the Laplace transform table or Laplace transform properties. Otherwise, for any transform, like the way I teach, like we should know these two things: transform table and transform properties. If we know the transform table and transform properties for any transform, like whether it is Fourier transform, whether it is Z transform, whether it is discrete time Fourier transform, we should know these two things: transform table and transform properties. So yesterday I have derived this transform. First I have derived the this one transform Laplace transform some standard function, and then I have derived this table like Laplace transform table. These are the standard functions where we have talked about the impulse functions, then step function, then we have the exponential signal, then we have the real signal, then we have the sinusoidal signal also. So we have find out the Laplace transform of all these functions with the ROC, because Laplace transform and Z transform, when I'm talking about, we should find out the ROC. ROC, basically ROC is called as reason of convergence. We have talked about the reason of convergence. Reason of convergence means it is the set of range of values of S. I'm just recapping like yesterday lecture just for 5 minutes, so that like if today someone is joining which have not attended the yesterday class, so they will also come on the same page. Okay, yesterday this was the things which we have covered. So it is the set of range of values of S for which Laplace transform of the signal xt is finite. So basically, a reason of convergence defined only for those values of defined for only those values of S for which Laplace transform of the signal is finite. So yesterday we have seen, like if I'm taking the step signal, like step signal is one of the standard signals. So if I will be seeing its Laplace transform is finite only for s greater than 0, and it is coming infinite for s less than 0. It means we can say Laplace transform of step signal u of t is 1 by s with ROC s greater than 0. Similarly, here also we have taken one more signal, step signal only we have considered, but this time we have considered the anti-causal step signal, like which is in the left side. So it is x of s is equal to 1 by s less than 0. Like we can say it would be Laplace transform of the signal is 1 by s, and ROC will be s less than 0. So I have concluded here. So basically we have two signals, time domain, different signals. This is also step signal, this is also step signal. But if we will see, this is basically uh, this is a causal signal, right side signal. This is left side signal. So its ROC is s greater than 0. Its ROC is s less than 0. Then we have seen exponential signal, and based on this, we have conclusion. We have made the conclusion like we can directly find out the Laplace transform, and this is Laplace transform table. We have concluded. Then we have talked about the Laplace transform properties. Where we have talked about the linearity property, time shifting property, frequency shifting property, time scaling property, time inversion property, convolution in time domain property, convolution in differentiation in time domain property, without initial conditions, with initial conditions. So we have seen all the properties: integration in time domain properties, differentiation in S domain, integration in S domain, initial value theorem, and final value theorem. So, and we have taken some signal after that, and we have find out the Laplace transform for these signals. Okay, now, so today our agenda is, first we will see how we can find out the with the help of ROC, how we can find out the causality and stability of the signal. And after that we will see, if we have the combination of two or more than two signals, then how we can find out the ROC for combination of the signal. Okay, so before that, like before I start, like today, whoever have joined, like we have some students here. So can you please tell me, like you people know what are the causality, causal signal, anti-causal, non-causal? At least you people can give me some idea, because yesterday I have talked about already about the causal signal, non-causal, anti-causal. If you people don't have idea, then I'll like first I'll introduce what is the causal, non-causal, and anti-causal signal, so that when I will be deriving the causality of the signal with the help of ROC, you people can understand, okay sir, now we can understand this is ROC and this is causal signal, and how we can derive the causality of any signal with the help of ROC. So whoever have joined today, students, can you please tell me, have you heard about the causal signal? Do you know anything about the causality of the signal, causal, non-causal, anti-causal? Anyone? That is the only thing I have seen. Like when I'm coming to asking, coming to this part, asking anything, I'm not getting any response. Students, I think you got my point. What I'm trying to say, I'm simply asking. It is. I think no problem. You should say, okay, sir, we don't know. So tell us that at least you can say this thing.
No, sir.
Okay, fine. So we will be starting with the causality of the signal, and then we will be going on, and we will be finding ROC with the help of ROC. So actually, causal. Uh, if I will see if I'm talking about the causality. So causality means, like we can say causal. We have three type of signal: causal, non-causal, anti-causal. And I'm talking about the in reference of signals. I'm talking about in reference of signals. We will talk about causal, non-causal, and anti-causal in reference of systems also. But as of now, we are talking about in reference of signals only. Okay, so signals, if I will say, so if I'm writing signals, then let me put the date today. Today we are starting by 14th of Jan. This is the lecture by 14th Jan. And previously we have done all these things yesterday in the class, 13th of Jan. Sorry, 2022 we have been entered now. Now, so causal signal means x of t is defined only for t greater than 0. Only for t greater than 0. It means I can say x of t will be equal to 0. X of t will be 0 for t less than 0. For t less than 0. Similarly, if I'm saying x of t is defined only for as x of t, if I'm talking about the anti-causal, non-causal I will be talking about after this anti-causal. X of t is defined only for t less than 0. Or I can say x of t is equal to 0 for t greater than 0. Okay. Now x of t is defined for t greater than 0 as well as t less than 0. Okay, so now we will see, students. So how we can say x of t greater than 0, x of t less than 0. X of t is defined only for t greater than 0. Suppose I'm going to draw some signals. Let's say this is x of t, this is t. Now again one signal x of t. Let's say x1t, this is x2t. Let me draw total 6 signals: x3t, x4t, x5t, and x60. Now, if I will be going to draw, like first signals I have drawn like this, second signals I have drawn like this, third signal I have drawn like this, Fourth signal I have drawn like this. Fifth signal I can draw like fine. I have drawn like this. Okay, and sixth signal I can draw like this one. Now, students, you have to tell me which one is causal, which one is non-causal, which one is anti-causal. So, students, if you will see, like since this is defined, if you will see, this is t is equal to 0 point. So t is equal to 0 point. Here it is defined for t less than 0. Here it is defined for t greater than 0 also. So can I say it would be non-causal? Because we have seen it is defined for t greater than 0 as well as t less than 0. If you will see again, it is defined for t less than 0, t greater than 0, then it would be non-causal. Now, students, if we will see, it is defined only for t greater than 0, because t greater than 0 it is defined, t less than 0 always it is 0. It means this is which signal? This is causal signal. So students, can you, I hope you got this point. So can you go on? Fourth signal, which one is this? Causal, non-causal, anti-causal. It is defined only for t less than 0. T less than 0. Then which signal is this? Anti-causal signal. Here, it is defined for t less than 0 as well as t greater than 0. Non-causal. Anyone can tell me sixth signal. This is causal, non-causal, anti-causal?
Causal.
Causal. Causal signal, because this is defined only for t greater than 0. So students, this is the only thing you have to remember about the causality of the signal that define. Now basically in the gate exam, in many exams, basically as of now they have given to you this thing: causality, non-causality, and anti-causality. But this thing becomes interesting and complex also sometimes, because they will not give you x of t. They will not give you x of t. What they will give? They will give x of s. They will give x of s, means Laplace. They will give you the Laplace transform of the signal, and then they will be asking, okay, just tell me the whether the signal is causal or non-causal. Then things becomes starting to complex, and that is the only point I say, like I always prefer to make that things very simple for the students perspective. Okay, so we will be seeing how we can find out the causality and stability. Yes, students, before moving on, I will talk about the stability also. Okay, because we are talking about the stability and causality. So stability, students, stability, we can say, if I will be defining the stability, for bounded input, output should also be bounded. For bounded input, output of the system should also be bounded. This is this is basically in respect of systems. But if I'm talking about the signals, if any signal is stable, then how I can say, basically I can say like this: the x of t should be less than equal to infinity. Basically, I can say its value should be b, and where b is a finite number. B is a finite number less than infinity, or I can say b is a finite number. Okay, we will see how now. So I will be talking about here stability. So if I'm saying stability, then let's talk about four signal. First, I will be taking x of t is equal to exponential minus let's say uh, 2t u of t. Second signal, I will be taking xt is equal to x of exponential 2t u of t. Let's say this is x1t, this is x2t. Let's say third signal, x3t is equal to exponential of minus 2t minus exponential of minus 2t u of minus t. And fourth signal, I will be taking minus exponential of 2t u of minus t. Exponential of 2t u of minus t. Now, so students, I have taken four signals. Now first I will be finding the Laplace transform of each signal. What is Laplace transform? X1s. Its Laplace transform is 1 upon s plus 2. And what would be the ROC? This is right side signal, so s greater than 2. Because ROC is for right side signal, ROC is greater than the pole, means right side of the pole. So we have the pole at -2, it means ROC will be s greater than -2. If I will be finding x2s, then its Laplace transform will be 1 upon s minus 2. And we can say its ROC will be s greater than 2. Similarly, x3s. So minus is already there. So 1 upon s minus, it would be s plus 2. And this is left side signal. So ROC will be s less than -2. And if I'm talking about x4s, then I will say 1 upon s minus 2, and ROC will be s less than 2. ROC will be s less than 2. Okay, students. Now, so we got the Laplace transform. After this, we will see we got the Laplace transform. I'm going to draw these signals. So exponential of -2t u of t. If I'm going to draw this signal, so exponential of -2t u of t. So if I'm going to draw this exponential of -2t u of t, the signal will be like this. Okay, now x of 2t, if I'm going to draw, students, so this is basically x of exponential of 2t. Exponential of 2t, if I'm going to draw, then it would be starting from here and it would be approaching to infinity, like this. It would be approaching to infinity somewhere. Okay, so so from the plot, this would be bounded, this would be bounded, and this would be unbounded, because it is reaching up to infinite. At infinity is equal to infinity, it would be infinity, but at t is equal to infinity, it would be tending to 0. Similarly, if I'm going to draw exponential of -2t u of t u of minus t, so this signal will be, if I'm going to draw this signal, so it would be started from, like if I will put 0, it would be starting from 1, and it would be also reaching to infinite, like this. And fourth signal, if I'm going to draw x40, so x40, if I'm going to draw, so exponential of -2t u of t u of minus t, because the students, you have to take care, u of minus t is defined only for t less than 0. U of t is defined only for t greater than 0. That's why these two plots came on the right side for t greater than 0, and these two plots is coming on the left side for t less than 0. And this signal will be like this. Like this. Okay, if I will draw it clearly, like this, it would be coming like this. Okay, so it would be tending to 0 at t is equal to infinity. Now, friends, if I'm talking about the from the plot, if I'm saying which is stable from the which is unstable, so from here I can say it would be stable, because it would not be infinity at t is equal to infinity, but it is reaching up to infinity, so it would be unstable. Similarly, here it is reaching up to infinity, it would be unstable, and it would be stable, because it is reaching to infinity at t is equal to, sorry, it is reaching to 0 at t is equal to infinity, or we can say minus infinity. Now, so from the plot, students, we got this is stable, this is unstable, this is unstable, this is stable. But if you will see, it is having pole where? At the left hand side. So we know pole at the left hand side means stable. Pole on the left hand side, pole on the right hand side means unstable. Pole on the right hand side, here pole on the left hand side at s is equal to -2, it means it would be stable. And pole on the right hand side, here pole on the right hand side, it means it should be unstable. So students, if you will see, here from the Laplace domain, we are getting it is stable. Time domain and Laplace domain both are saying it is stable, fine. Time domain, Laplace domain both are saying it is unstable, fine. But here, if you will see the case number 3 and 4, case number 3 and 4, here Laplace domain says that it is stable, but time domain says that the same signal is unstable. Similarly, Laplace domain says that this is unstable, and time domain says that this is stable. It means something is going wrong. it means something is going wrong, because these two cases not these two signals are not proper, because its Laplace domain is saying that this signal this should be stable and this should be unstable, but time domain says that no, 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 this is unstable. Similarly, its Laplace domain says that this is unstable, but it says that no, 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 this is stable. So it means somewhere there is a problem with this uh, third and fourth. So it means there is a problem with the concept which we have learned till now. This system is unstable. I will tell you how this system will be unstable, and this would be stable. I will tell you how it is happening, like this. It would be stable. Okay, fine. So now we will see how we can conclude, and all those points we will be talking about here now. So if I'm saying stable, unstable, so stable and unstable, unstable, stable. Huh. So students, here if you will see, if I'm going to draw the ROC, so ROC, its ROC is s greater than -2. S greater than -2 means here pole at -2, and s greater than -2 means this. This is sigma, this is j omega axis. I'm going to draw the ROC in S plane. Here, this is sigma, this is j omega axis. This is S greater than 2. So 2 will S is equal to 2 will be here. This is the ROC. Now, it means this is sigma, this is j omega axis. Sigma and j omega axis means I'm talking about the S plane. Now, S less than -2. So -2 is this. S less than -2 means this point, this side. And here also next point, S, this is sigma, this is j omega axis, and S less than 2. This is point 2, and S less than 2 means like this. Like this. Okay, it means students, see, ROC, this is the ROC. We know this is for stable signal. This is for unstable. This is for unstable. And this is for stable. Okay, so if I will be concluding this unstable, stable, so what is the common between these four? Common in these four is I will be highlighting those common points: stable, stable, and this is unstable, unstable. So students, what is the common between these two? The ROC of a stable signal cross the j omega axis, because if you will see this ROC and this ROC cross the j omega axis, and this ROC and this ROC does not cross the j omega axis. It means I can say, make a note and I can write down ROC of a stable. Students, I will be using the system basically I'm saying these signals are the impulse response, whatever I have taken, x1t, x2t. Let me write it down here. If I'll show you this x1t, x2t, what I have considered, x1t, x2t, x3t, x4t are the impulse response of any system. Okay, so we can say these are the impulse response of any system. If impulse response of the signal is absolutely integrable, then system will be stable. So I can say ROC of a stable system includes j omega axis. Includes j omega axis. And ROC of a unstable system does not include j omega axis. Does not include j omega axis. So students, please remember this. If ROC includes j omega axis, it means that would be stable. If ROC does not include j omega axis, it means it would be unstable. Now we have to write down some more points, students. We have to write down some more points. We have talked about the stability. If ROC includes j omega axis, then stable. If ROC does not include j omega axis, then it would be unstable. Here we have seen, okay, sir, but how it is getting happen? Like here, when the pole is in left hand side, then it is stable. Here the pole is in left hand side, but you are saying this is unstable. So how we are saying? Just remember, a system, a system with all the poles on left hand side, on left hand side is stable if and only if the system is a system with all the poles on the left hand side is stable if and only if the system is causal system. Causal system. Okay, if you will see, students, this is causal system because this is on the right side. Causal system, this is defined, and this is anti-causal because if you will see, u of t is defined only for t greater than 0, and u of minus t is defined only for t less than 0. So this is causal signal, this is anti-causal signal. So causal signal is stable if all the poles on the left hand side is all the poles is on left hand side. So we are writing the same thing. If system with all the poles on the left hand side is stable if and only if the system is causal system. I can write down an anti-causal system. An anti-causal system is stable if and only if all its pole lie on the right side. Lie on the right side. Okay, so lie on the right side means, if you will see, if this is anti-causal signal, students, if you will see, this is anti-causal signal and pole lie on the right side, that's why it is stable. So an anti-causal signal and anti-causal system is stable on if and only if all its pole lie on the right side. Okay, this is the first point. Now we can go for the second point. Second point, what is the second point? Second point, I can say a causal system becomes unstable if one of the pole lie on the right side. While an anti-causal system becomes unstable if and only if becomes unstable, I can say when one of this pole, its pole lie on the left side. Lie on the left side. Okay, similarly, third point I can write down, if there is simple pole on j omega axis, then it is called marginally stable. It is called marginally stable system. Okay, if there is a simple pole on j omega axis, irrespective whether it is, students, irrespective, I can say irrespective, or I can say if there is a simple pole on j omega axis, then it is called marginally stable system, uh, uh, for causal and non-causal system both. Anti-causal system both. Okay, means if there is a simple pole on j omega axis, if there is a simple pole on j omega axis, then it is called as marginally stable system. Either it is causal or anti-causal system. If there is a repeated pole on j omega axis, then system becomes unstable. Unstable system. Okay, students. So basically, I have defined the stability and instability in terms of ROC as well as the poles. So students, here, if you will talk about in time domain, like it would be, sorry, in S domain, if I'm talking about with respect to pole, then we have to remember if it is a causal system or anti-causal system. If it is a causal system, then I can say the pole should be on the left hand side, then it would be stable. If the pole is on j omega axis, then it would be marginally stable. If there is a repeated pole on j omega axis, then it would be unstable system. If there is one of the pole lie on the right side, then it will become unstable. In opposite of this, if I have the I have anti-causal system, then anti-causal system is stable if and only if all its pole lie on the right hand side. If one of the pole lie in the left hand side, if one of the pole in the left hand side, then system becomes unstable. If there is a simple pole on j omega axis, then system is marginally stable. And if there is a basically repeated pole on j omega axis, then system is unstable system. Now, students, I'm telling you the important point. I'm telling you the important point. In books, you will see only this statement: a system, a system with all the poles, all the poles in left hand side. If left hand side of the omega axis is always stable, is always a stable system. Okay, students, in some of the books, and or I can say in control system, you will see this sentence. You will see this sentence: a system with all the poles in left hand side of j omega axis is always a stable system. Okay, here I know, students, you people are in second year. Like yesterday someone has told me you all are in second year, so now you have not idea of the signal system and control system might be. But Laplace transform, as I was telling you yesterday also, again I will repeat the same thing. Laplace transform is one of the important topic which you will be dealing with the Laplace transform up to higher studies. Means till the time you will study, you will be coming across the Laplace transform. The first point, Laplace transform, if you are studying the signal system, then Laplace transform will be used. If you will in, I think in your fifth semester you will be studying this control system, then also Laplace transform will be used. I think some of you have studied the network theory. Anyone have studied the network theory? Can you please tell me? Network theory is, you people have seen the network theory, like Thevenin's theorem, Norton's theorem, superposition theorem, Millman's theorem. Anyone? That is the main problem, you people
Yes,
doesn't
yes,
respond.
yes, sir. Yes.
Yes. So network theory is done. So they are also like, if you will study the transient response, then also you is this Laplace transform is used. So Laplace, that's why I have taken this topic like Laplace transform. Whenever we will be dealing with the core branch means even in the analog also we use this Laplace transform, and for solving the problem mostly this Laplace transform is used. So basically in control system, when you will be people will be studying, you will see only this line: a system with all the poles in the left hand side is of j omega axis is always a stable system. And I will say it is incorrect statement. I will say it is incorrect statement, but still all the books of control system, you will see this statement only. All the books of control system, you will see, even standard books also written by the foreign author, you will see this statement, then you can ask me, sir, this you are saying it is incorrect statement and still book is writing only this statement. Then where is the problem? So students, more than incorrect, I will say this statement as a incomplete statement. Incomplete statement. Incomplete statement. Why incomplete statement, students? Because we know this statement is complete when I will talk about the causality. Like a causal system with all the poles in the left hand side of j omega axis is a stable system. If I'm using the causal word here, then this sentence is getting complete. But when I'm not adding this causal system here, if I'm writing a system with all the poles in the left hand side of j omega axis is always a stable system, this is incomplete sentence statement. Why? Because when I will be having anti-causal system, then system will become unstable. Just now we have seen anti-causal system, if all having one of the pole in the left hand side, then it becomes unstable. Then so what is the reason behind it? Because students, in control system always we talks about LTI causal system. LTI causal system. LTI causal system. Okay, I will tell about what is LTI and what is causal. We have already seen. Now, causal even system, we will talk about LTI causal system. Okay, if I will say in practical, or a real word, I will say in practical or real word, a real word, only causal system exist. Only causal system exist. Okay, no anti-causal system and non-causal system does not exist practically. Anti-causal system and non-causal system does not exist practically. Here we will be talking about anti-causal and non-causal also in signal system, but it would be completely hypothetical theory. In real world, I will say in practically only causal system exist, and that's why control system always, when you will start with the control system, always there will be a line that in control system they will be talking about the LTI causal system. So by default, if they are not writing causal system here, by default the system would be causal, and that's why this statement will be complete statement. And you will see in all the books this statement: a system with all the poles in the left hand side of j omega axis is always a stable system. So students, please don't get confused. Why I'm telling you, you will be coming across these statement many times. You will be writing in any of the exam, and that is the simple point and most confusing points. And I will say, if I'm going to interview any students, then I can make them confused based on this causality, in anti-causality, non-causality, stability and instability. I can make anyone confused easily, because people are not clear about this concept. Okay, so like LTI, L for linear system, and TI means time invariance. So always in control system we talks about the linear time invariant causal system. Linear means system should behave linearly. Time invariance means it should not vary with the time. It should be not vary with the time means it should be remains, its behavior should remain same with respect to time. And causal system, I have told you, causal, we have talked about here causal signal, but causal system means output of the system is depending on the past input. If I'm talking about the causal system, students, causal system, how I can define the causal system? Causal system means output depends on present and past input. Okay, if I will be defining anti-causal system, so you can see anti-causal system from the definition, you will get to know anti-causal system. Anti-causal system, how I can define: a system in which present output depends on future input. Future input. Future input means, students, future input. So do you think is there any system possible, including time machine, which can tell you the output for the future input? Is there any system possible, like in the present world, if you will see, even as of now, time machine has not been properly developed. A system in which present output depends on the future input, means output in the present is depending on the input for which we are going to apply in the future. Definitely it is not possible in the current scenario. That's why anti-causal and non-causal system does not exist properly. But when there will be any system, that would be considered as anti-causal system, and analysis will be based on the same on anti-causal system only. So that's why it is completely hypothetical theory as of now, but slowly, like as of now, time machine, people are approaching to time machine, they are going in the future with the help of time machines. Then definitely this would be one interesting topic to study: anti-causal system and non-causal system. Okay, so I think we have seen what is our conclusion or observation from this topic. Like ROC of a stable system includes j omega axis, and ROC of a unstable system does not include j omega axis. You have to remember these 2 points, and it would be the problem for us will become very simple. Now after this, I will be talking about the combination. Like if I'm going to find out the combination of ROC of the combination of signals. Okay, now I'm taking the combinations of the signals, and then we will see how we can find out the ROC. So I will be taking 4 signal: first, second, third, fourth. So let's say x1t is equal to exponential of minus 2t ut plus exponential of 3t ut. Second signal I'm taking, students, x2t is equal to exponential of minus 2t u of minus t plus or again I will say this is minus exponential of 3t u of minus t. X3t I can take, students, exponential of let's say minus 2t u of t minus exponential of 3t u of minus t. And fourth signal I will be taking exponential of minus 2t minus exponential of minus 2t u of minus t plus exponential of 3t u of t. Exponential of 3t u of t. Okay, now, so actually if you will see, students, this is right side signal, this is right side signal, so I can say this is the combination of two right side signal. This is left side signal, this is left side signal, so this is the combination of two left side signal. This is right side signal, this is left side signal, so it is the combination of right side and left side signal. This is left side signal, this is right side signal, so again this is the combination of right side and left side signal. So now we will see what is the ROC. So students, what is the Laplace transform of this? 1 upon s plus 2. And what is the Laplace transform of this? 1 upon s minus 3. So here the Laplace ROC we have seen yesterday. If you have followed my yesterday lecture, I have told you clearly. I have told in that lecture very clearly, like after seeing this function, directly we can write down the Laplace transform with the help and including the ROC also. Here, if you will see, I have told here, like I have concluded, and with the help of examples also I have told, like exponential of minus 80 u of t Laplace transform is 1 upon s plus a. ROC will be s greater than minus a. And if we have minus exponential of minus 80 u of minus t, is Laplace transform is 1 upon s plus a. ROC is s less than minus a. So this we have discussed in detail in yesterday lecture, in previous class lecture, basically I will say, and just go back, have refer that video, and then it would be very easy for you to understand like how I'm able to write down this very easily. So s greater than minus 2, it's ROC, and here ROC will be s greater than 3. Now students, so now I will see what is the overall ROC. So if I will see, students, overall ROC, basically overall ROC is common ROC between these two, s greater than minus 2. This pole is minus 2, and s greater than minus 2 means this. Now, if I'm saying s greater than 3, so s greater than 3 means, students, let me write down it here. S greater than 3, 3 will be here, and s greater than 3 means like this. So what is the overall ROC? Overall ROC, students, means common ROC, common ROC between these two. So what is the common area? Can I say common ROC is s greater than 3? So I can say x1s is equal to 1 upon s plus 2 plus 1 upon s minus 3, s greater than 3. This would be the common ROC, students. Now I will not consider this s greater than minus 2, s greater than 3. Overall ROC will be this. Overall ROC means common ROC. Now, similarly, students, I will be talking about next one. So next we have x2s. X2s, what is the Laplace transform of this? 1 upon s plus 2. And what is the Laplace transform of this? 1 upon s minus 3. Its ROC is s less than minus 2. Its ROC is s less than 3. Now I'm going to find out the common ROC. S less than 3. S less than 3 means this much. Okay, and s less than minus 2. S less than minus 2 means this much. Like this. Okay, so what is the common ROC, students? Again, common ROC is s less than minus 2. So we can say this is the common ROC. X2s is equal to 1 upon s plus 2 plus 1 upon s minus 3, s less than minus 2. That would be the overall ROC of this signal. Okay, now we will talk about the third signal. So third signal, if I'm saying x3s, I will be finding. So what is the Laplace transform? 1 upon s plus 2. And what is the Laplace transform? 1 upon s minus 3. Okay, students, some people are getting confused, sir. Minus negative sign is there. So negative sign is there. Students, yesterday we have considered when u of minus t is there, it should be negative of u of minus t. Then it would be coming positive. If you will not put this minus sign, then it will become negative. So it is up to us. Similarly, negative sign is there. That's why we are keeping this as a positive. If this would be positive sign, then this would become negative. Okay, now if we know what is the ROC here, this is right side s u of t. That's why ROC is s greater than minus 2. Here this is left side signal. That's why s less than 3. Overall ROC will be, now if I will be finding overall ROC. So what is overall ROC? Common between these two, s greater than minus 2. S greater than minus 2 means, okay, s less than 3. S less than 3. Okay, so what is the common ROC, students? Common ROC is s greater than minus 2 less than 3. S greater than minus 2 less than 3. So this is the overall ROC. S greater than minus 2 less than 3. This is the overall ROC, students. So you should forget about this. What is this? Just we have to take care of the common ROC. So what is the common ROC or overall ROC? S greater than minus 2 less than 3. Okay, now similarly we should go for the fourth one, x4s. So what is the Laplace transform? 1 upon s plus 2, and here it is 1 upon s minus 3. So ROC is s greater than s less than minus 2, and here s greater than 3. So now if I'm going to draw the, so s less than minus 2, s less than minus 2, S greater than 3. Now, students, if I'm asking you, can you please tell me what is the overlapping area or what is the common area? No common ROC. Can I say there is no common ROC? No common ROC. Because students, you can see here it was the common, it was having the common ROC. Here it is also having the common ROC. Here also it is having the common ROC, but here we don't have any common ROC. So since there is no common ROC, if I will say since there is no common ROC, so its Laplace transform does not exist. Its Laplace transform does not exist. So students, please remember in this case, we won't say x4s will be this. We won't say x4s will be this. No, its Laplace transform does not exist. Why its Laplace transform does not exist? Because there is no common ROC. So please remember there is no common ROC. Since there is no common ROC, that's why its Laplace transform does not exist. So please remember students, whenever we have the combination of two or more than two signals, and if there is no common ROC, then we can say Laplace transform of that signal does not exist. If I will take the example, I'll take the example. Let's say example is we have xt is equal to 4. Xt is equal to 4. Xt is equal to 4 means this is a DC signal. This is a DC signal where xt is equal to 4 from minus infinity to plus infinity. Like this, it would be continue up to 4 from minus infinity to plus infinity. From minus infinity to plus infinity. Okay, so now xt is equal to 4. So students, I have to find out the Laplace transform of 4. So how I can write down first? Laplace transform 4. Now this can be written as u of minus t plus a u of t. Because from minus infinity to 0, u of minus t, from 0 to infinity, u of t. So basically I can say 4 can be written as, if I will be writing like this, 4 can be written as 4 u of minus t plus 4 u of t. Okay, it means xt can be written as 4 u of minus t plus 4 u of t. Okay, students. Now if I will be finding u of minus t, what is the Laplace transform of u of 4 of u of minus t? Minus 4 upon s and s less than 0. That would be the ROC. Here 4 upon s. Here 4 upon s. 4 upon s and s greater than 0. S greater than 0. So students, if I'm asking you what is the common ROC, if you will see s less than 0, s less than 0 means this, and s greater than 0 means this. What is the common ROC? No common ROC. No common ROC. Again, can I say it means Laplace transform Laplace transform of DC signal does not exist. Does not exist. So students, like this, there are many signals for which Laplace transform does not exist. Like I have given you two examples. This one is this signal, DC signal. One is like this signal where no common ROC exists. DC signal does not exist. Okay, so please remember this point. This is important point, students. You will see many people, you will get if you will be asking Laplace transform of 4, they will say this is a 4 by s. No, Laplace transform of 4 or a DC signal does not exist. 4 by s is the Laplace transform of 4 ut, or this is the Laplace transform of minus 4 u of minus t based on the ROC. If s greater than 0, then 4 u of t. If s less than 0, then minus 4 u of minus t. Minus 4 u of minus t. That would be the uh, Common arrows basically s greater than 0 and s less than 0. That is the Laplace transform. Okay. Now, similarly, if I'll take one more example, if I'll give you then one more example, let's say signum t. If I'm asking you Laplace transform of signum t. So, students, you will see all these functions I was telling you. There are three standard functions. First one is the impulse signal, step signal, and ramp signal. Okay, but like when you will go deep in the signal system, there are some important standard functions again. Like we have the rectangular function, we have triangular function, we have sync function, we have sampling function, we have signum function, we have exponential function, we have lot more functions. Okay, so signum function is one of that, and signum function is defined basically like this. Its value is plus 140 greater than 0, its value is minus 140 less than 0. That is the signum function. Okay, this is the signum function. And this signum function can also be written as, like if you will be writing, signum function can also be written like this: u of t minus u of minus t. This is the definition of signum function. Okay, it means I have to find out the signum function Laplace transform. It means in place of signum function I can put this value. Okay, and as per the linearity property, we know this can be written as Laplace transform of u of t minus Laplace transform of u of minus t. So Laplace transform of u of t is 1 by s and s greater than 0, and Laplace transform of u of minus t is minus 1 by s greater s less than 0. So again, s greater than 0, s less than 0, what we can say? No common ROC. And again, no common ROC, it means Laplace transform of signum function does not exist. Okay, students. So like this, we have talked about the ROC of the combination of the signals. Now, yesterday I have taken some signals for which I told, I will be discussing their ROC in detail. So yesterday I have taken one signal cos hyperbolic 80 u of t. Cos hyperbolic 80 u of t. So yesterday, students, we have written its Laplace transform is s upon s square minus a square, and we have write down its ROC s greater than a. So we will see how we have write down s greater than a directly. So cos hyperbolic 80 u of t, I have to find out its Laplace transform. And now we know cos hyperbolic exponential of 80 can be written as exponential of 80 plus exponential of minus 80 upon 2 u of t. I will take this 1 by 2 outside, and we will say Laplace transform of 80 u of t plus Laplace transform of exponential of minus 80 u of t. Exponential of minus 80 u of t. Now I will be finding the Laplace transform, students. So what is the Laplace transform of 80 u of t? 1 upon s minus a. And exponential of minus 80 u of t, 1 upon s plus a. What would be the ROC here? S greater than a. And what is the ROC here? S greater than minus. Okay, students. Now, S greater than A, if we will see again, since we have the combination of two signals, then I can find out the common ROC. So S greater than A means, let's say this point is A. So this one, and S greater than A means this one, this part, and S greater than minus A means this part. Okay, it means what is the common one? Common is s greater than a. Common is s greater than a, so that would be the common one. We have to write down the common only. So common is s greater than a. Now if I will be solving it further, so 1 by 2, and if I will be taking the LCM, s plus a plus s minus a upon s square minus a square, and a get cancel out, we will be having 2s, 2 get cancel out, s upon s square minus a square. And what is the ROC? S greater than a. This is the Laplace transform of cos hyperbolic at u of t. Okay, s greater than a. So that is the reason, students, I was telling, which I have told, like I will be telling you later. So that is the point which I need to discuss here. I have discussed. Okay, there is one more point. Yesterday, like when I was teaching this Laplace transform of sine, we have seen cos 80 u of t. Cos 80 u of t, we have seen Laplace transform is s upon s square plus a square, and there we have written s greater than 0. ROC is s greater than 0. And I was telling you when I was writing, I will tell you the reason later when why we are writing s greater than 0, why we are not writing s greater than a. Because students, if you will see, there is a reason behind it, because that was cos hyperbolic 80, that was the real function. But if I will be writing Laplace transform of cos 80, so cos 80 function written like this: exponential of I 80, that iota square root of minus 1, that complex imaginary part which shows the imaginary one. So I stands for square root of minus 1 iota, basically we can say. Exponential of iota 80 plus exponential of minus iota 80 divided by 2 u of t. Okay, now further, if I will be seeing, students, 1 by 2 I can take outside. Laplace transform of exponential of iota 80 u of t plus Laplace transform of exponential of minus iota t 80 u of t. Okay, now I will be finding its Laplace transform. So what is the Laplace transform? Laplace transform is like I can say, what is the Laplace transform? Laplace transform 1 upon s minus ia plus this is s plus ia. And if I will be finding its Laplace, its ROC will be s greater than 0, and its ROC will be also s greater than 0. So why it is happening in this way, sir? S greater than 0 you are writing. Why you are not writing s greater than IA or s greater than minus IA? Why you are not writing like the same? Why you are writing s greater than 0, s greater than 0? Why we are writing in this way? Because, students, there is one point. The thing is, we have to take care of the real part of the pole. A real part of the pole. A real part of the pole. So when I will be taking the real part, if you will see, what is the pole here? Pole is ia. A pole is a. So what is the real part? Real part is a. But if I will be seeing what is the pole here, pole is at s is equal to ia. What is the real part here? A real part here is 0. Can I say like this? 0 plus ia. So what is the real part? The real part is 0, and that's why we are saying this as a s greater than 0. So always remember, we have to take care of the only real part. A real part. Suppose I'm saying 1 upon s minus 3 minus j4. So if, students, if I'm asking you, can you please tell me what would be the ROC? So its ROC either will be s greater than 3, because real part will be at 3, or its ROC will be s less than 3. Definitely you can't say that s greater than 4, s less than 4. You can't say s greater than 3 minus j4. No, nothing. Like, or you can't even like say like this also, s greater than square root of 3 plus square root of 4, that s greater than 5. This is also not correct, this is also not correct, this is also not correct. We have to take care of ROC will be either right side of real part of the pole or left side of real part of the pole. So these two ROC will be correct only for this. These all are incorrect ROC. I hope the things got clear for you people.
Yes, sir.
Okay, great. Okay, so that's why students, yesterday, like when I was teaching this, like I have told, I will be teaching this later. So that is the point which I need to discuss here. And like if I will be solving, so common ROC will be s greater than 0. And now if I will be solving it further, I can say 1 by 2, and I will take the LCM, s plus iota a plus s minus iota a upon s square minus I square a square. Okay, and ROC is s greater than 0. So now I can write down 1 by 2, and iota a and iota minus iota a get at cancel out, 2s upon s square. And we know iota is equal to square root of minus 1 is I square. If I will say iota square, that is minus 1. So minus minus will become plus 1, that is. And if I will be writing, this can be written as s upon s square plus a square. And what is the ROC? ROC is s greater than 0. So is it means cos a t u of t Laplace transform is s upon s square plus a square, s greater than 0, which I have already written in this Laplace transform table. If you people will see here, so everything has been written in this. Cos a t u of t Laplace transform is s upon s square plus a square, s greater than 0. And that is the reason, students, I was telling you, if you want to learn any transform, because I think you all people are in third year now, third semester now, so you have to study in Laplace transform, or Fourier transform, Z transform, discrete Fourier transform, discrete time Fourier transform, DTFT, DFT, and all those things you have to study. So what is the what I will say, what is the easiest way to learn all these transform? Just understand these two things very properly. One is the transform table, and another one is the transform properties. If you will learn these two things, then easily you will be able to understand, and you will be able to solve the problem based on Laplace transform, Fourier transform, Z transform, discrete Fourier transform, discrete time Fourier transform, FFT. There are lot many transform in the signal system, so you will be easily able to understand and learn all those things if you learn this Laplace transform table and transform properties. Okay, so we have talked about the combination of the ROC of the combination of the signal. Then we have talked about the causality and stability. Yes, I was talking about the causality, and I have to conclude this causality here, which I missed here. So students, if you will see here, this is right side, this is right side, means this is causal and this is also causal, because right side signal means causal only. So this is causal, this is causal, students. It means I can say right side, if I'm talking about the right side signal, the ROC will be, I can conclude here. uh, See, what is the ROC? S greater than 3, this is for right side. And left side means, students, left side means, like this is left side signal u of minus t, this is also left side signal u of minus t. Or I will say more than left side, I will say anti causal. See, this is causal, this is causal, and ROC is s greater than 3, s greater than 3. Similarly here, if I will say this is anti-causal, because u of minus t is defined like this, it is defined only for t less than 0. So this is anti-causal. For anti-causal, what is the ROC? ROC is s less than minus 2. And for non-causal, if you will see, this is causal. Causal means defined for t greater than 0, and this is anti-causal, defined defined t less than 0. It means overall signal x of 3t will be non-causal signal. And non-causal signal, what would be the ROC? The ROC will be s greater than minus 2 less than 3. Okay, it means if I will be concluding, students, then what kind of ROC it would be having? Then I can say s greater than s naught. If I'm writing s greater than s naught, it means this is the ROC for causal signal. ROC for causal signal. causal signal. And if I'm writing S less than S naught, it means this is the ROC for anti-causal signal or anti-causal systems, I can say. Okay, and then if I'm writing S greater than S1 less than S2, then what would be the ROC for this would be the ROC for non-causal. Non-causal. Okay, so I think students, now I will be taking the examples, and with the help of examples we will see, with the help of ROC we can comment the stability and causality of any systems very easily. Okay, let me take the example. Suppose I have written S less than minus 1. Suppose students, I have written S less than minus 1. So now ROC of any system, I'm saying ROC of any system is given as S less than minus 1. I'm simply asking, can you please tell me that system is stable, unstable, causal, non-causal, or anti-causal? Then I hope everyone, please tell me, can I say this would be anti-causal? At least you can say yes or no. You people can say anti-causal, because if you will see the ROC of which kind, ROC of S less than S naught, that's why I can say this would be anti-causal signal or anti-causal system, I will say. Okay, don't get confused between signal and systems. Like I will what I'm saying, I will tell you. Okay, so students, like suppose if I'm saying this is a signal, like let's say this is a signal h of t, this is a signal. If I'm going to draw, this is the signal, like this. Okay, but when I'm saying this is the impulse response of any system, now it is exponential of 2t, u of t is representing the system. When I'm saying this is the impulse response now, then it means it is representing one system. So that's why I'm saying don't get confused between system and signals. Like sometimes sir, you are writing system, sometimes you are writing the signal. No, we are talking about the ht, that is the signal only. But when it is impulse response, it means its transfer function will give you the system transfer function, or its Laplace transform will give you the system transfer function. So when I'm saying this is the impulse response of any system, then it means this is the system, otherwise this is the signal only. So we are saying the same thing now. So this is anti-causal system. Now, anti-causal system, with the help anti-causal system. Now, if I'm talking about the ROC, sorry, stability and instability. So anyone can tell me that whether this is stable or unstable. Students, you can tell me now, because you have been got this concept easily. Okay, S first I will locate this. S is equal to minus 1. S less than minus 1 means this is the side. Less than minus 1 means this side. It means its ROC will not include the j omega axis. Then I can say it would be unstable. It would be unstable. Clear, students?
Yes, sir.
Okay, great. Now, so now we will go for with the next example. Suppose, and ROC will always be like there is one more properties of ROC. ROC is I can say, or I can say basically here properties of ROC. Because if we want to know the Laplace transform, first we should understand properly the ROC. The first point I will say, ROC never includes any pole. ROC never includes any pole. It is either right side of the pole. It is either right side of the pole or left side of the pole. Okay, so either right side of the pole or left side of the pole, ROC is bounded by the poles. ROC is bounded by the poles. Okay, students. Then suppose I'm saying so what does it mean from these 2 points? ROC is either right side of the pole, ROC is left side of the pole, ROC never includes on the pole, ROC is bounded by the poles. Now, if I'm saying that a system has 4 poles, let's say a system has 4 poles, 3, 2, minus 1, minus 5. I am saying a system has 4 poles. A system has 4 poles. Okay, we have these poles at 3, at 2, at minus 1, at minus 5. Okay, now students, now I'm saying that possible ROC. Students, possible ROC can be s greater than 3. This is the possible ROC. This is one of the possible ROC. S greater than 3 means right side of the pole. Okay, s greater than 3. This is one of the possible ROC. Then sir, when I'm writing s greater than my s greater than 3, sir, s greater than 2 can be the ROC? No students, s greater than 2 will not be the ROC. Why s greater than 2 will not be the ROC? Because when I'm saying s greater than 2, it means it would be including the 3 pole which is located at 3, and we have write down ROC never includes the pole. ROC never includes any pole. So that's why S greater than 2 cannot be the ROC for this system. Can never be the ROC for this system. Either it would be, we can say it would be having 3 choice only. Either it would be S greater than 3, either it would be S greater than 3, or it would be S less than minus 5. Like this side, if I'm talking about, this side, if I'm talking about, s greater than minus 5, or this side if I'm talking about s greater than 3, or it can be like this, s greater than minus 1 less than 2, greater than minus 1 less than 2. It's 100. This is minus 5. This is minus 5. This is minus 1. Okay. Similarly, s greater than minus 1 and s less than 2. These can be the 3 possible ROC. Like this. Okay, we from the here we can say s greater than 3 means for this ROC system will be causal system, because this is the ROC for which system will be causal. This is the ROC for which system will be anti-causal, and this is the ROC, we can say this is the ROC, this is non-causal. This is non-causal system. Okay, in which case it would be stable. It would be stable here s greater than 3. No, because ROC does not include the pole. So here it would be unstable. Similarly, it would be unstable. It would be stable here s less than minus 5. No, it would be unstable here. It would be s greater than minus 1 less than 2. It means yes, it would be stable here. Why it would be stable? Because students, if we will see, it is include j omega axis in this case. That's why for this ROC system would be a stable system. So that's why students, like this we can easily conclude with the help of ROC only whether the system is having so causal system, anti-causal system, non-causal system, whether the system is stable or unstable system. So I hope students it would be clear for all of you now.
Yes, sir.
Okay, great. So now we will be going forward. So we have talked about as of now we have talked about the basic things of Laplace transform. So where we have talked about the Laplace transform table, Laplace transform properties. After that we have seen how we can find out the how we can comment on the causality and stability of any system with the help of ROC only. Then we have talked about how we can find out the ROC of the combinations of the signals. And I think most of the theory part we have covered. So now we will be focused on the basically this one. Basically, now we will be focused on the problems. So I will be taking some problems which have been asked in the GATE exam, which is really very good from the concept perspective. And then I will be taking some other problems also. Okay, so let's talk about, yes, I will be taking next one more type of problems, like some of the problems we have done yesterday. So we can say they have given if x of t Laplace transform is 2 upon s plus 3. 2 upon s plus 3, and its ROC they have given s greater than minus 3. S greater than minus 3. So they have been asked us, we have to find out the Laplace transform. Find Laplace transform of following signals. Like part A, I will be talking about x of t minus 1. Part B, x of t plus 2. Means third part, we have to find out exponential of minus 5t x of t. D is, I will be seeing x of minus t. Next, we have to find out the Laplace transform of x of 2t minus 3. Next, we have to find out Laplace transform of x of minus 2t minus 3. And next, we have to find out the Laplace transform of d by dt x of t convolution with, okay, let me go one by one. X of t convolution with x of t minus 1. Next part, we have to find out the Laplace transform of d by dt x of t convolution with x of t minus 1. And in the last, exponential of 2t d by dt x of t convolution with x of t minus 1. So students, these are the basically signals for which we have to find out the Laplace transform. If we already given to us like x of t Laplace transform is 2 upon s plus 3, where s greater than, and I will be taking x of t minus 1, x of minus t. Yes, everything we have covered here. Yeah, I will be taking one more signal. Yes, it has been already covered. D, yes, already covered. No problem. Now, so I will be taking students one by one, and you can write down one. Okay, fine. We can cover it here only. Otherwise, you can take exponential of e d e. So I will take one more part, like e h I j. J is x of, let's say x of 2t. Okay, fine. So we have to find out the Laplace transform of all these signals when already we know the Laplace transform of x of t. That is 2 upon s plus 3, when where s greater than minus 3 is the ROC for this Laplace transform. Okay, fine. Now I will be talking about the answers for all these. Okay, so first part. Now, Laplace transform of x of t minus 1. So Laplace transform of x of t minus 1, students, we have seen as per the time shifting property, what would be the Laplace transform? Exponential of minus s x of s. And x of s already given to us. This is x of s. So I can say exponential of minus s. And then what is the value of x of s? 2 upon s plus 3. So I can say this is 2 exponential of minus s upon s plus. And what would be the ROC? ROC remains same. Okay, I will be coming to this point, students, why ROC is same here. And in the next signal, Laplace transform of x of t plus 2. So this can be written as, again, I'm applying the time shifting property, students. Yesterday we have talked about all these properties, students. That's why I have taken this example. This here I'm going to use time shifting property. If I will be writing time shifting property here, also time shifting property here, also it is frequency shifting property, it is time scaling property. Okay. Sorry, time not scaling, it is time inversion property. Yesterday we have talked about the time inversion property. This is time scaling property. Okay, here we have scaling as well as shifting both. Here we have the scaling and shifting. Okay, here we have scaling, here we have the shifting, here we have the inversion also. Okay, and here we have the time convolution in time domain. Okay, and then we have the convolution and then differentiation in time domain property. So all these property, students, we have seen yesterday. So like if you are facing difficulty, you can just go back and watch the previous video, and then you can continue with these problems. X of t plus 2. So as per the time shifting property, what is the Laplace transform? X of s. X of s, and we can say exponential of 2s. 2x of s value is 2s plus 3. So this can be written as 2 exponential of 2s upon s plus 3. And what would be the Laplace trans? What would be its ROC? ROC will be s greater than minus 3 less than infinity. Less than infinity. Sir, how it has been happened? Now, if you will see from the ROC itself, it is getting clear. This is right side signal. Right side signal, or we can say causal signal. Okay, now yesterday we have seen, if I'm shifting right side signal to the right side, because I'm shifting this signal x of t minus 1 means I'm shifting this signal right by 1 unit. Here I'm shifting by right, sorry, to the right side. Here I'm shifting it to the right side by 1 unit. Okay, and here I'm shifting it to the left by 2 unit. Okay, so that's why, students, yesterday, if you have remember, we have talked about in previous class that if I'm shifting the right side signal to the right side, then ROC does not change. If I'm shifting right side signal to the left side, then ROC will be changed. Okay, yesterday we have talked about this point very clearly. If I'm shifting right side signal to the right side or left side signal to the left side, ROC does not change. But if I'm shifting right side signal to the left side or left side signal to the right side, then ROC changed. Okay, so same thing is happening here, because the given signal is right side signal and I'm shifting to the right side here. That's why ROC don't get changed. And since this is right side signal and I'm shifting to the left side, that's why ROC is getting changed here. Now, third signal, if I will be taking exponential of minus 5t x of t. So as per frequency shifting property, students, like its Laplace transform will be x of s plus 5. So what I will be getting? I will be getting 2 upon s plus 5. In place of s, I will put s plus 5. So I will be getting 2 upon s plus 8. And in the ROC also, we can say s plus 5 greater than minus 3, means in place of s, I will be getting s plus 5. So s greater than minus 8. This would be the ROC now. Now I will be taking fourth signal, that is x of minus t, that is d part, x of minus t. So Laplace transform of x of minus t. So Laplace transform of minus t, we have seen it would be x of minus s. It means I will be getting 2 upon minus s plus 3. And in the ROC also, this would be replaced by minus s, means s would be replaced by minus s. Here, wherever they have in ROC, we have s, we will be replacing this s by minus of s. So this can be written as s less than 3. So students, we know if you this is right side signal, if this is right side signal, its time inversion signal will be left side. And even from the ROC also, we can say yes, this is the ROC for left side signal only. Now, I will be taking this signal. Fifth part, I will be taking this x of 2t first, time scaling signal. So x of 2t, Laplace transform of x of 2t. Okay, x Laplace transform of x of 2t. So we know as per the property, yesterday we have seen time scaling property, and let me write down time scaling property for you people so that a Laplace transform of x of at Laplace transform is given as 1 upon mod of a x of s by a, and ROC we will change s with s by. So we have seen this yesterday, this property. So I'm just going to use this property directly. 1 upon mod 2 x of s by 2. Okay. So 1 upon mod 2 is 1 by 2. X of s by 2 is 2 upon s by 2 plus 3. So when I will be solving this 2 to get cancelled out, I will be getting 2 upon s plus 3, s plus 6. And in ROC, s would be replaced by s by 2, s by 2 greater than minus 3. So we can say s greater than minus 6. S greater than minus 6. Okay, so this would be the ROC. So its Laplace transform, I will write down like this way, that Laplace transform of x of 2t is 2 upon s plus 6, and ROC is s greater than minus 6. Now, next one. Next one is interesting, students. X, we have to find out the Laplace transform of x of 2t minus 3. Here I will talk about in detail, because here actually we have the shifting property also, and we have the scaling property also. We have the shifting property also, we have the scaling property also. Means we are scaling in time as well as we are shifting in time. So students, I will talk about in detail. Might be you know this concept till now or not know, but when you will talk, when you will study in signal system, then you will study in detail. But I'm telling you in very short. Like, many students I have seen, they are saying, sir, whether we should go for time scaling operation first or time shifting operation first, whether we should go for time scaling operation first or whether we should go for the time scaling operation first. So students, I will say you can go for any operation first. Either if you want, you can go for the scaling operation first, and if you want to go for the shifting operation, then you can go for the shifting operation first. We are completely free. We are not bounded that we have to go for the shifting first. But there is a certain rule. What is that rule? I'm going to tell you. X of t. So students, if I'm going to shift it by shifting first, then I have to shift by 3. I have to shift by 3, then I will be getting xt minus 3. And then I will be scaling by 2. I will be getting scaling by 2, and then I will get x of 2t minus 3. But if I'm going for scaling first, I'm going for scaling first, scale by 2. Then I will be getting x of 2t. Now I have to shift by 1.5, not by 3. I have to shift by 1.5. So now if I will be shifting it by 1.5, so I will be getting like this, and this would be x of 2t minus 3. So students, there is a certain rule. What is the rule? If you are going for shifting first, then shift by 3 and then scale by 2. But when you are going for scaling first, then first you have to go for the scale by 2 and then shift by 1.5. So now we can find out, and we will be getting the same answer. Okay, so let me show you. Let me show you. So x of t, I'm going for scaling, shifting first, shift by 3. So I will be getting x of t minus 3. Now I will scale it by 2. I will be getting x of 2t minus 3. Its Laplace transform is capital X of s. What would be the Laplace transform? This exponential of minus 3s x of s. And what would be its Laplace transform? I'm going to scale by 2. So it means 1 by 2 exponential of minus s. Every s would be replaced by s by 2. So what would be the answer? 1 by 2 exponential of minus 1.5s. And we already know the value of x of s. X of s. What is the value of x of s? This 2 upon s plus 3. So I can find out the value of x of s by 2. 2 upon, so this can be written as 1 by 2 exponential minus 1.5s and this is uh, okay 1.5s, and this is 4 upon s plus 6, and this 2 4 divided by 2, so I will be getting 2 exponential of minus 1.5s upon s plus 6. And then ROC also, ROC this uh, since we are shifting it to the right side, we have the right side signal, we are shifting it to the right side. ROC will not change because of the shifting operation, but it will be changing due to the scaling operation. So s by 2 less than 3 less than minus 3, and here I will be getting s less than minus 6. This would be the answer. So I can write down it here as less than minus 6. This is the answer. Now I will be solving it in by scaling operation first. Students, I'm going to tell you in detail because you will be having confusion later, sir, why you are not going for the scaling, for the shifting first or scaling first. Okay, so first we have done with the first method. Now I will go for the second method. X of t scale by 2, then I will be getting x of 2t, then shift by 1.5. Then I will be getting x of 2t minus 1.5, which I will be getting x of 2t minus 3. Now I will be writing Laplace transform. So its Laplace transform is x of s. Its Laplace transform is 1 by 2 x of s by 2. And then its Laplace transform is 1 by 2 x of s by 2. And we are shifting by 1.5. So that's why exponential of minus x. See, this one and this one, we are getting same. 1 by 2 exponential of minus 1.5s x-axis by 2 x-axis by 2. So directly I will write down the answer. What is the answer? 2 exponential of my 1.5s divided by s plus 6. And what would be the ROC? ROC will be s less than minus 6 will be the answer. So I hope, students, this would be clear. So there should not be any confusion that why, sir, we should go for the scaling first or shifting first. We can go for the shifting first. We can go for the scaling first. Only thing we have to take care, if I'm going for shifting first, then shift by 3, then scale by 2. If I'm going for scaling first, then scale by 2, and then shifting by 1.5. Now I'll go for the seventh part. Seventh part is after x of 2t minus 3. Next signal is x of minus 2t minus 3. Then find x of minus 2t minus 3. And x of 2t minus 3, we can say x of minus 2t minus 3 is time inversion signal of x of 2t minus 3. So we can say Laplace transform of x of 2 minus 2t minus 3, we can say this would be equal to, s would be replaced by minus of s here. So I can say 1 by 2 x of minus s by 2 exponential of 1.5 s. Because, students, this is the time inversion signal of x of 2t minus 3. So whatever we have the Laplace transform of x of 2t minus 3, in that Laplace transform, we will replace s with minus of s. So what I will be getting? I will be getting this as a 2 exponential of 1.5 s upon minus s plus 6, which can also be written as 2 exponential of 1.5 s upon 6 minus s. And here I can say the ROC will become minus s less than minus 6. It means ROC will become s greater than 6. S greater than 6. That would become the ROC. Okay. So S will greater than 6. That would be the ROC. Now we will go for the next one. So what is the next part? Next, we have to find out the Laplace transform of x of t convolution with x of t minus 1, dt, d by dt x of t convolution with x of t minus 1, and then h and I part. Okay, fine. So let's continue. Eighth part. We have to find out the Laplace transform of x of t convolution with x of t minus 1. So we know that, students, yesterday we have seen x of t convolution, two signals. Convolution in time domain means multiplication in s domain. So Laplace trans multiplication in s domain, it means Laplace transform of xt multiplied with Laplace transform of x of t minus 1. So this is Laplace transform of xt is capital X of s, and Laplace transform of xt minus 1 is exponential of minus x capital X of s. So this can be written as exponential of minus s x s whole square. So x of s whole square. So I can just put the value of x of s. So we have 2 upon s plus 3 whole square exponential of minus s. So what would be the answer? 4 upon s plus 3 whole square exponential of minus s. Okay, and ROC will be s less than s greater than s less than minus 6, s less than minus 6, where it has been changed. I have write down something wrong ROC here. Okay, yes, I have changed the ROC from here, students. Actually, the ROC actual ROC was s greater than minus 3, but by mistake I have taken this as a s less than minus 3. So if I will be writing it correctly here, so this would be greater than. Here also it would be greater than. Let's see. So here the actual ROC was s by 2 should be greater than minus 3. That's why s greater than minus 6. Here this would be the ROC. And if we are seeing uh, here also it would be s greater than minus 6 because we have just shift, and here also it would be s minus s would be replaced and then s less than 6. This would be the answer basically. And here, if I will be seeing what would be the ROC, the actual, because this signal have the ROC as greater than minus 3, and this signal will also don't change the ROC. Why? Because we are shifting right side signal to the right side. So ROC will not get changed. So S greater than minus 3 will be the ROC. Now I will be taking next signal. Next signal is given as d by dt x of t convolution with x of t minus 1. We have to find out the Laplace transform of this. So if I will be finding the Laplace transform of this signal, students, we directly know, I can directly write down this would be equal to s multiplied by Laplace transform of x of t convolution with x of t minus 1. Yesterday we have seen the time domain differentiation in time domain property. So s Laplace transform of x of t minus 1, which we have already. So 4 exponential of minus s upon s plus 3 whole square. And yesterday we have seen differentiation in time domain property does not change the ROC. It means ROC still will remain same, s greater than minus. Okay, that is the ninth part. Now I will be taking the 10th part. So 10th part will be equal to 10th part. I will be taking Laplace transform of exponential of, what is exponential of? We have 2t. Exponential of 2t d by dt exponent x of t convolution with x of t minus 1. So we can say again, so this would be equal to means in this if I will take this part in the Laplace transform of this one, what we have to do, whatever is the Laplace transform we got for this part, as per the frequency shifting property, s would be replaced with s minus 2, because this would result into which one? Frequency shifting. It will result into frequency shift. So we will apply the frequency shifting property, and as per the frequency shifting property, what I can say, whatever we got the Laplace transform here, s would be replaced by s minus 2. So we will be getting, students, s minus 2, and then it would be exponent 4s minus 2 exponential of minus s minus 2, or this can be written as 2 minus s upon s plus 1 whole square. S plus 1 whole square, and ROC will be s would be replaced with s minus 2. This would be the answer. So like this, students, we can use the properties of Laplace transform and we can solve the problem based on Laplace transform. We have seen some problems yesterday and then some problems we have solved now. Now, students, there is one more important concept based on Laplace transform. So we will be taking that problems also. Okay, now Laplace transform of causal periodic signal. Okay, now what does it mean, Laplace transform of causal periodic signal? Now we can say Laplace transform for periodic signal does not exist. Does not exist. What does it mean, sir? Just now we have seen Laplace transform of cos 80. So, but here you are saying Laplace transform for periodic signal does not exist. So, students, if someone is asking you, can you please tell me cos 80 or Laplace transform of sin 80? So we can say Laplace transform of cos 80, Laplace transform of sin 80. These does not exist. Does not exist. Why does not exist, students? Because same thing what we have discussed before, like a DC signal, sine of 80, cos of 80, these signals are repeating itself from minus infinity to plus infinity. Suppose if I'm saying sine 80, like this, and it would be repeating from minus infinity to plus infinity. So that's why we can say sine Laplace transform of sine 80 can be written as, so Laplace transform of sine 80 can be written as basically Laplace transform of sine 80 u of t, u of minus t, plus sine 80 u of t. So here Laplace transform of sine 80 u of minus t, what would be the ROC? S less than 0 because of this u of minus t. Here what would be the Laplace transform? S greater than 0. And again we can say no common ROC. No common ROC. That's why Laplace transform of periodic signal. That's why Laplace transform of periodic signal does not exist. Then, sir, you can ask me, sir, but just now only before some time you have said Laplace transform of cos 80 u of t is S upon S square plus A square with ROC S greater than 0. Yes, this is correct, students. Why? Because now I'm talking about the causal periodic signal. We have talked about U of t. U of t means now it would be starting from 0 to infinity. U of t means this here left part it would be 0. Only right part is there. Only right part is there. So that's why S upon S square plus A square. So be careful, students. If someone is asking you the Laplace transform of only cos 80, it does not exist. But yes, they can ask you cos 80 where t greater than 0, where t greater than 0, they can ask you like this. So when I'm saying where t greater than equal to 0, it means this whole line means the same thing, because ut basically ut says that it is defined only for t greater than equal to 0. For t less than 0 it is not defined. So that's why. And similarly, if I'm writing sine 80 u of t, so sine 80 u of t Laplace transform will be a upon s square plus a square s greater than 0. So that's why, students, already mentioned here, we are talking about the causal periodic signal. We are not talking about only periodic, we are talking about the causal periodic, which is periodic after t greater than 0. So let's say causal periodic. I'm going to draw one signal. Causal periodic signal means we have one signal like this, which is causal periodic. Causal periodic means which is repeating itself from 0 to infinity. F of t, like this. This is 1 from 0 to t, like this. It would be continued. So students, if you will see, it is repeating itself after every t time period. What is the time period? Time period is t. Okay. Now if you will see this f of t, can I write down like first cycle of periodic signal is equal to f1t. First cycle means I'm representing this first cycle in this way up to this point. T by 2, this is 0. F1t. Okay, so how I can write down F1t. Now the second period, how I can say, basically second period I will get the same if I will shift it by capital T. If I will shift this signal by t times, then I will get the same signal. Similarly, this can be written as f of t minus 2t. Similarly, this can be written as f of t minus 3t, and it would be continue up to infinity. So students, if I will be writing Laplace transform of ft, if I have to find out, so it would be equal to Laplace transform of f1t plus Laplace transform of f1t minus capital T, Laplace transform of f1t minus 2t plus Laplace transform of f1t minus 3t, and it would be continue like the same. And now Laplace transform of f of t, this can be written as Laplace transform of f1t plus this can be written as exponential of minus st using time shifting property. Laplace transform of f1t plus this can be written as exponential of minus 2s2t, Laplace transform of f1t plus exponential of s3t, Laplace transform of f1t, and continue up to infinity. And further, students, I can write down Laplace transform of ft is equal to Laplace transform of f1t plus we can say we have taken this as a common 1 plus exponential of minus st, exponential of minus s2t plus exponential of minus s3t, and it would be continue up to infinity. And this is basically what this is. if this is basically a, we can say, GP of infinite terms. Okay, so I can say, if I will be solving, then I can say Laplace transform of ft is equal to Laplace transform of f1t. And what would be the sum up to infinite number of terms? A upon 1 minus r. What is A? A is equal to 1. And what is common ratio? Exponential of minus st. So I can say 1 upon 1 minus exponential of st. And what is the condition for this? A upon 1 minus r, mod of r should be less than 1. It means mod of exponential of s minus st should be less than 1. It means I can say, what is the Laplace transform? Laplace transform of ft will be equal to Laplace transform of first cycle. That what is f1t? First cycle of periodic signal upon 1 minus exponential of minus st. And what is the condition? Condition is exponential of minus st should be less than 1. This would be the Laplace transform. Mod of minus st should be less than 1. Like this, students, we can find out the Laplace transform of a causal periodic signal. Okay, so we have talked about almost all the concepts of Laplace transform till now, students. So now only practice is remaining. So I hope you will be able to do the practice, and you will be able to solve the problem based on Laplace transform comfortable. If any doubt, then definitely you can ask me. So now with this, we can just wrap up this session, and we will, yes. So we have almost completed or almost discussed all the concepts related to Laplace transform. Thank you.
Thank you, sir.
Thank you.